Hi everyone, in this video we're going to be finding the limit as x tends towards 0 of sine of x over x using the Maclaurin series for sine of x. The idea here being twofold. First of all, of course, we need to know how to find this limit. And secondly, this video will show us that we'll often be able to use Maclaurin series in order to find or evaluate limits. So let's go ahead and get started. As I always do, I'll start by writing SOL here for solution. And a good starting point would be to actually show that this limit, so limit as x tends towards 0 of sine of x over x, leads to an indeterminate form. Indeed, as x tends towards 0, sine of x tends towards 0 as well. So we can already state that the numerator for this limit is equal to 0. And that would be over the limit as x tends towards 0 of the denominator x, well, that's of course just 0. But 0 over 0 is an indeterminate form, so we can't draw any conclusions from this result. And so the idea here is, since we're interested in the limit as x approaches or tends towards 0, we can replace the sine of x we have on the numerator here by the Maclaurin series for sine of x. And if you're studying Maclaurin series or Maclaurin expansions, you no doubt already know that the Maclaurin series for sine of x is equal to x minus x cubed over factorial 3 plus x raised to the power of 5 over factorial 5 minus x to the power of 7 over factorial 7, and so on and so forth. So underneath here, I'll go ahead and say using Maclaurin series. There we go. And I'll go ahead and underline that, like so. Okay, well let's see. Therefore I can rewrite this as limit as x tends towards 0 of sine of x over x is equal to the limit as x tends towards 0 of the Maclaurin series for sine of x. So that's what we have written in the upper right hand corner of the screen here. And so I'll go ahead and write all of that. That would be x minus x cubed over factorial 3 plus x to the power of 5 over factorial 5, and it carries on forever that way, and all of that would be written over x. And of course I close the parentheses here. There we go. Notice now that every single term in this series is being divided by x. And so consequently this x will turn into 1, this x cubed will turn into x squared, this x to the power of 5 will turn into x to the power of 4, and so on and so forth. In other words, this is equal to the limit as x tends towards 0 of 1 minus x squared over factorial 3 plus x raised to the power of 4 over factorial 5, and we could keep on going if we needed to. And now looking at the expression we have here, it's quite clear that since we're considering the limit as x tends towards 0, all of these powers of x's will tend towards 0. In other words, this x squared over factorial 3 will tend towards 0, so will this x to the power of 4 over factorial 5, and so would all the other powers of x that follow. And of course, the 1 that we have at the front here, well, it's not affected at all by the fact that x tends towards 0, it stays 1. And consequently, this limit is equal to 1. And so we could state as our final answer that the limit as x tends towards 0 of sine of x over x is equal to 1. And I'll go ahead and box that final result. And there we go. That's an example of how Maclaurin series can be used to evaluate limits. And something that's quite important to realize here is that thanks to the Maclaurin series for sine of x, we were able to rewrite this limit, which initially led to an indeterminate form, as a limit which was relatively easy to find. Indeed, it took us no time at all to see that that limit was equal to 1. And this is just one of many examples showing how useful Maclaurin series can be. There we go everyone, I really hope that helped, and if it did, please hit like on this video, drop a comment down below, and even subscribe to this channel to help get this video to as many students as possible. All that being said and done, that's it for this tutorial.